Hey guys, thank you for your patience. I've finally gotten some time to put together an outline of what I'm looking for the curriculum development tasks that you agreed to help me with, and thank you for doing that. So I've got a document here I'm going to share with you shortly, which has a section on the C++ class, kind of what it needs, and a section on the Java 2 class and what it needs, and the people that are have agreed to work on the different classes. So my thought is I'm going to kind of give you a rundown on each class, and then kind of point you to some of the issues where you can help me out. And each person, or you can work in a team if you like, would pick one of these areas and work on it. And I'm going to be out tomorrow, this Friday, but I will be in the lab in the classroom on next Friday, the 20th. If you want to come down and have a meeting at that point, kind of show me what you got, that'd be great. What I'm hoping to do is have you all this week just pick one of the areas to work on, review the course materials for the class, and then I think I recommend to get a big sense of the big picture. Look around in the weeks before and after what's going on in the class, so you get a feel for what the trend is before you kind of propose some stuff to do. And then I'd like you to make notes about the course content that you're kind of encapsulating in your sense of the big picture. You know, what the topics were, what the lab activities were, just to kind of get yourself grounded into what's going on there. And then I kind of suggest working through some of, or all of the assigned tasks. There's videos you can watch, which I kind of step through some of them. And the solutions I've also dumped into the shared folder. You can look at those. And then develop a plan for how you're going to improve the content. Could be complete redesign. I'm actually totally in favor of that. Or it could be maybe a modest or not so modest revision. Most of them kind of need a lot of work. That's why I'm pointing into those. And then, think about, can you think of some real world engaging problems that would cover most of the language features or concepts suitable for a problem-based learning activity, which might excite people and get them involved. Maybe something more contemporary. Some of my stuff is getting a little dated. But at the same time, I want to anticipate ways so that we don't allow weak students to kind of get swept aside by some advanced students. I'm afraid some problem-based learning activities might be a little too advanced, but that's something we could talk about. And anyway, it's actually okay. I can maybe fill in weaker students with other activities if the problem-based learning is too advanced. So I think I want you to sort of be free to brainstorm, come up with something that really excites you, because most likely that's going to be what excites other people as well. And then if you can bring a proposal to NPC next Friday, 10:21 or 10:20, I don't know if you are available, but I will be there at 2 p.m. And if you want, before that, you could develop a problem statement for the revision, for the revised lab. Develop a solution, and ideally develop some lecture slides that would illustrate some of the the statement, the problem statement or topic, the steps that you would need, and of course not the whole thing, but just to kind of give people some grounding in what actually is going on in this lab, to kind of help them do that. And so, like some of the labs I'm going to show you, the problems are actually kind of cool, but there's no good setup for the students, so I have to do a lot of hand waving or just talking them through, which kind of wastes time and creates more confusion and stuff. So we want to kind of streamline this so it's really effective, kind of quick, and gets to the point and gets people excited and engaged right away. So that's what I'm looking for, and if you could do that by next week, that would be great. Also, while we're talking about logistics, I kind of recommend that, because you do need to kind of maybe document, and your class teacher for this service learning class probably tells you this, but one way I've been working with my students to document their time is to fill out a form with just the date, what activity they worked on, and how many hours they worked on it. And if you keep a record like that, that will probably be good enough to justify your service learning requirement in your class. But if you have some other thing, that's fine too. Okay, so let's get to the meat of the problems, and it is a challenge because a class, in many ways, is like a novel, and trying to correct chapter 10 of Moby Dick and fix it and improve it is a little challenging if you haven't read the whole novel. And I don't expect you to read the whole novel, the whole class, but I'm going to give you kind of a rundown on what the general themes are. So this is sort of the Cliff Note version of the class, or at least some of the intentions of the class. Starting with the C++ class, this class, it serves a lot of purposes. Originally, we've only had a CS1 and a CS2 class in Java for the last few years. The C++ class came along as a way to give people some pre-learning in C++ before they transfer, say, to CSUMB. And it is an intermediate level class. It's not required like a CS1 or CS2 is, but it's highly recommended, and people seem to enjoy taking it because they want to get more experience coding, and they know it's a tough field. Excuse me a second. Right, so the intention of C++ is to fill in people's C++ abilities, teach them the language enough so that they could, after having taken 10A and 10B in Java, they could go ahead and do pretty much the same work in 10B, but now in C++. So working with stacks, queues, lists, data structures, and all that stuff in C++. It's a little stretched. Look at some of it, but they should have a pretty good grounding in those kind of topics. So, for that reason, because it's sort of intermediate level, people will come into C++ with at least one other programming course. It's not a real basic course. It's an intermediate course, and it could be a number of different languages. And some people could have taken the Java 2 class first, but I also recommend people take the C++ class before Java 2 because that will make them work better, perform better in Java 2. So therefore, we have a pretty big spread of incoming ability and experience. Then there's also this hardware component with an Arduino that kind of keeps things a little bit off kilter compared to a normal programming class. And right now, I've drawn. Right now, the course is composed of a hodgepodge of stuff, some old C++ CS1 material that I used to use years and years ago, and some Arduino content that I got from Cabrillo, and some more recent C++ material that I used from another textbook. It's a real patchwork, and I would like to kind of unify it and clean it up, but that takes a lot of time. So right now, I'm sort of thinking that there is some foundation drill stuff, which maybe tends to be overdone, but I think it can be really useful for beginners to have that experience. I don't want to lose them with some more advanced stuff. But I think the idea of splitting the class into foundation drill activity students and mastery challenge activity students would be really beneficial, and kind of give people a sense that they are, they're learning at the level that they like to learn at. And some of the drill exercises are just a lot. I've kind of throw like 2 weeks worth of drill exercises in one class, so it kind of gets a little overwhelming. So some of that stuff can be thrown out, I'm sure. As far as your access to the material, there are several different links. There's a public access to the Canvas course. I'm showing you this in Firefox so that you can kind of see how you can access it without logging in at all. And there is a web repository if you just want to go straight to that. This is where all of the content resides. Canvas is just a front for the website that I'm hosting. And if you know what week you want to get to, you can click on that week and grab the materials for that week. Sometimes, in most weeks, there is a download, like a starting zip file. And there's usually a lecture PDF, a lecture PowerPoint, and a lab PDF as well. Sometimes the lab is to some web page elsewhere. But yeah, there's a lot of different varieties of content here. So this web repository, there's a syllabus, so you can kind of get a look at the general layout of the class, and the order of the topics can kind of help you find different things. There's a couple different textbooks I'm using. And then also I have lecture videos. So if you're doing something, working on a topic that we've already covered, you can look at the current year's semester's lecture videos. If you're looking at something if you're looking at something ahead of where we're covered, you can look at last year's coverage of the same topic. And I've actually provided links to the particular lecture that covers the lab that I'm asking for help on. But if you want to, you can go and poke around and look at any of the lecture videos. The entire class is available here for you to kind of peruse if you find it useful, if it's something you want to look up or something. Okay, so in the C++ class, my goal is to inspire you, or to inspire us with some kind of project or problem that might be really really contemporary and exciting for people to kind of work on in the context of learning some of these basic things. And starting with Lab 4, which is a lab on functions, you can kind of get a sense of what that looks like here by clicking on that link. And this is the handout. This kind of shows you the type of drills that I've give. Typically, well, this one actually is a little bit unique. There's a guide, which something else. You just got a lot of these things. This is from previous semesters. This is from my old C++ class, which takes you through a long-winded story generator. It's kind of fun, but a little, maybe a little tedious, and maybe we can kind of streamline that. These are just an introduction to void functions for absolute beginners to programming. I think this is a little bit too slow for people in 10C, given that they've already had a programming class. So this could be, reduced or thrown out with place of something else. Then there's a discussion on function prototypes and signatures. Of course, nobody reads this. It's just too much. It's too verbose. And then there's value returning functions that people work on as well, and a discussion of how that all works. So at the end, they're writing different functions, void functions, value returning functions. They learn how to generate function headers from the surrounding context, all that stuff in excruciating detail. And I think it's just not terribly interesting for people to kind of tackle at this point. Kind of overlong and kind of hard to grade all those little drill exercises, and a little tedious for the advanced students. So can we do something to kind of make it accessible for beginners, but also have advanced students maybe doing a separate assignment, or I don't know, some other thing? I'm even thinking like that Sphere Engine tool that I showed you to do a competition kind of challenge for the advanced students would be really nice, but not require the beginners to do it, just the advanced students. There's a problem where you calculate shipping cost with different weight and sizes and stuff, and it's a fairly complex logic thing. And that could be really good for a Sphere Engine type of problem. There's also a lab on strings, which is kind of messy. It covers a lot of ground. We're going to cover files and strings in the same week. Again, the drills seem to be a little bit tedious and overlong. And they're also hard to grade. And again, I think some of these things could be really useful for a kind of an automated grading competition thing, where a challenge problem where people have to kind of solve it with a bunch of different test cases to be, to work properly. I did add a 5B lab to kind of bring in more what I thought was realistic applications of string processing, but a lot of it seemed to go over people's head. I had to do a lot of typing. I don't like to do that. So again, if you kind of look through all this stuff and say, hey, I've got a better idea for a string activity, covers all these, points, and it's really consolidated and concise, and great, that'd be good. I'd really appreciate that. There's a lab on compiling projects with multiple classes, separate file compilation. It's a real headbanger, and it's a PC option. People don't have to do it. They can do an Arduino option. But it's pretty crazy, and it comes from another source. I can show you that source. So that's the one I think I clicked on accidentally earlier. This guy here is a lab from another textbook activity. And what they're doing is they're making a a pretty convoluted project like a bank loan project, a bank loan class, which has a bank class as an element, objects of a bank class. So they're taking something that was given to them and they're adding a bank class to it. So that they're already starting with a project that has like 3 different classes and they're adding a 4th one to it. And then there's a contact class, which kind of represents like a phone number and all the methods, functions that go with that. Starting zip file. It's really challenging, and I don't want to give something that just perplexes people. There should be something that's, a little less cryptic, I think. If you try this yourself, you'll have fun, I think, working on it. And you'll see what I mean. And then there's another one, and there's more. If you scope around and see something else that strikes your fancy, feel free to just jump in. But these are just things I'm highlighting, and you can watch the lecture video for any of these. The inheritance one is just something I've just used for so long. I'm just kind of tired of it. It's just a paper I wrote up to kind of explain some of the topics of inheritance. It may not even be that good. You probably have a better understanding of it now than I did in this document. So. And the activity is really sort of minimal, just following a pattern. It's not really good application. So one thing I thought is that maybe a more realistic example of inheritance, maybe something that ties into the final project, which would be a great thing, to integrate stuff with something else that's going on in the class. The recommended final project I have is this Zork game, which is from Drexel. It's a really fun project. It covers a lot of different bases using pointers and vectors and all kinds of things. And there's a ton of extra credit they can do, which, in my opinion, you should be able to implement some of these things using inheritance. And, that could be a thing where you just say, well, let's look at this project, and here's some of these extra credit things. Well, you can sort of do this using inheritance. And you can kind of flesh out some of that, and maybe work out some kind of, activity based on that. Not necessarily, straight out of the this game project, but maybe it just helps them, see how they will do that later. So that's the C++ class, and again, you could spend a lot of time just kind of exploring the class. This is why I think 30 hours won't be too much of a problem when you kind of think about how much is involved in doing the kind of work involved in curriculum development. So that's for the guys, and then for the women, you can all work on that Java 2 class. If you guys want to work in teams, that's fine too. Or if you want to switch, if you don't want to do Java, you want to do C++, I don't mind either. So as far as the Java 2 class, the way this one is laid out, I've taken taught this enough that I think I have a pretty comfortable framework for it. I'm much happier about this class than the C++ class, but even it needs a lot of work. About 4 years ago, I got tired of people getting really confused when when the first time they approach like a data structure class, and they're supposed to like build it and then use it in the same week, and people just get completely wigged out by, well, where am I? Where does this code belong? And they get stuff really confused. So what I did, because our textbook allows it, textbook by Carano for Java data structures, it actually separates the use of the data structure from the implementation, and what that allows is for okay, good. That allows for me to break the class up into segments, because for the first few weeks of the class, people really need a lot of review. There's a lot of really weak students, trying to make it in the advanced class. So we got to go over a lot of topics again, and then sort of prepare them for what's to come. So we introduce inheritance and stuff like that in the early weeks, because that's what they're going to use later on. And we introduce the data structures as as just like APIs. You know, here's what you can do with a bag, here's what you can do with a stack, here's what you can do with a queue, but we don't actually show them how to make it yet. Just want to get them familiar with these things and just say, yeah, you're going to be building your own in a little bit, but you got to learn how to work with arrays again. You got to know how to use these things called linked nodes. We do all that in the first segment of the class. And there's a test. And then after that, we go into the second module where we build these things. So we're going to build a bag, we're going to build a queue, a list, and all that stuff. And we do it in arrays, and we do it in linked nodes. And they get the feel. Now they're working on the implementation. Okay, that makes it clear. And then there's another test on that. And then in the third module of the class, the last module, they actually branch out into more complicated structures. And that's where things get a little more messy. Stuff is thrown at them a lot, faster, and it can be a little challenging for people to keep up. And the material's a little less well organized. Again, there's a public access to the class, which you'll be able to pull up right here, and you can kind of scope around and grab and look at anything in there. There is a web access. It's a little bit different because there's a front page on the website for this version of the class, which gives you access to all these things in a little more transparent way. Sometimes Canvas can obscure things in an annoying way. And there are also a syllabus you can look at and a video playlist you can look at to pick up any of the lecture videos you want to look at. And then again, I've kind of gone through and added video links to all the stuff I'm looking for help on. So just kind of running down the area that you might want to look at. Lab 3 is kind of a preview of the kind of data structure operations people are going to do on arrays. And it's an introduction to linked nodes without a whole class. There's a linked node class, but there's not like a list class that the linked nodes are in, which can kind of really throw people. So we play around. It's sort of a way of just sort of playing around with things, and it's supposed to give people a practice in the kinds of array operations and linked list algorithms that they're going to be using when they're working on these other data structures later, without having to worry about all that object-oriented passing of into instance methods and whatever, instance variables and methods and all that. You'll get a sense of how ineffective it is. I'm doing a lot of typing of people, kind of explaining hand-wavy stuff. I really don't like that. I think this could be cleaned up quite a bit, where people are getting a brief presentation and then left on their own to develop the solution to the different steps. And I think those steps could be redone as well. So it's less maybe less drill oriented, more open-ended. Same thing for linked nodes. The two are kind of parallel. So that's an example. And then Lab 4B is an example of applying lists to an ASCII slideshow. So they have to read a file of ASCII slides and load it into a list of slides, and then play it, and so it's kind of nifty and it gets the idea across. But there is a lot of we actually talk about exception handling. There's a lot of great stuff in here, but I think it could be improved. And again, maybe a completely different approach. Sort of basically the point of this is a list application, so people can understand the value of what's cool about lists. And a good list application, this slideshow isn't maybe the best idea for a list because you don't actually move anything around, but maybe we could ask them to sort it or reorganize the list, because that's what lists are really good at. I don't know. Think about that. And you're welcome to email me if you have any ideas you want to bounce off me as well. And then there's another lab which is a little messy: basic sorting algorithms and Big O introduction. It seems like it's trying to do too much. We're trying to cover sorting, Big O, how to sort, in Java, sorting primitive arrays versus object arrays. And the arrays class has these sort methods. I like to show people how to use those. I think they're very valuable. But I also want to have them write their own sorting methods so they can do that as well. Maybe I should get rid of one of those things. But I have a list of possible approaches. If people want to kind of play around with that, that's fine. It'd be really interesting. Hashing is another area that's kind of gets pretty messy. We start the class with a very simple example that we build together, and that kind of, I don't mind doing, leading people through some typing exercise that way, because it does kind of help show the process of constructing these things. But then I want to show them the code provided by the publisher, the author, which is much more advanced and more realistic, and have us kind of play around with it a little bit. Again, if you have a better, better way of talking about introducing hashing, I'd be interested in seeing that as well. It doesn't have to be anything like what we've got here. Lastly, binary search trees. Again, I think it's sort of tucked in later, and I don't think it's given really necessarily the best treatment. But again, we sort of build a simple binary search tree. The question is, what else do you do with binary search trees? What can you do with binary search trees that would be interesting? I think we could definitely use some help there. So that's the rundown of areas that I'm looking for help in. Hopefully this isn't too overwhelming. I suggest you just sort of focus on something that appeals to you. It could be in a different class than you initially were intending to work in. And explore it, kind of play around with what's already there. Take some notes, document what you're doing, make a report. You're gonna probably want to write up something after all this is done. So think of it like a research project. Take a lot of notes, document everything, and then hopefully you'll have something by next Friday to kind of run by me. And if not, we can talk some more. I can work with you in person if that's preferable. So that's the idea. If there's any questions at all, just get in touch with me, and we'll take it from there. So thanks again for your help, and hopefully I'll see you next Friday. I will be away this coming weekend, but I will answer my email when I get back on Sunday. So talk to you soon. Bye.